This is a full GCSE Paper 3 from the Autumn 2022 series. So it's a calculator paper and it was used for the Year 10 PPE in April 2023. Okay, in this question we just have to rearrange the formula to make A the subject. Very simple here, just a couple of steps. So we start with P, we add the 9 to both sides, and that will give us 3A. But we only want A, so we need to divide both sides by 3. So we can simply conclude that A equals P plus 9 over 3. And that's it. Okay. Okay, here we have just a 1-mark question about ratio. Rob has done something wrong, and you've got to explain what it is. Best thing is to do it right, and then you'll see what was wrong. So I'm going to put that he should have done this, okay? And then if you can do that, you usually answer the question quite quickly. He should have done 120, okay, and he should have divided it by 8, which came from 3 plus 5, okay, and 120 divided by 8 would have given 15, and then he would have had 3 times 15 is 45, and 5 times 15, that's the other side of the ratio, would be 75. Okay, so what he should have ended up with was 45 to 75. Okay. In this question, we've got information about 200 students studying languages, either French, Spanish or German, and the students are boys or girls. So we solve this with a two-way table, something like this. Okay, so we set up 3 rows like this, or 2 rows, and then we divide that vertically into columns, and they will represent the languages. Okay, and we'll do it something like that. Okay, so across the top we are going to have the languages French, Spanish and German. Along the side here we've got B for boys and G for girls. Okay, we're told that there are 200 students and 90 are boys. So if 90 are boys, that's the total number of boys, then we can say that there must have been 110 girls because the total is 200. We know that there are 70 who chose Spanish, so we'll put the 70 underneath there, you see. Okay, and we know that 60 of the 104 students who chose French are boys, so 60 must go in there, and because there's 104 students who chose French, that must be 44 in there. Okay, and then we know that 18 girls chose German, so that must go in there. Okay, and now we should have enough information to complete the table. So that's done fairly quickly. Now let's finish this off. That's 110. We've got 44 and 18 already. Add them together and subtract from 110 leaves us with 48. Now that we know that's 48, we know that this must be 22 because we're told that there's 70 people doing Spanish, and that's what we need. Work out how many boys chose Spanish. Okay, so there's the answer, and that's all we need to do. We don't even need to finish the table off. So I'm just going to write that down, and that's the question done. Okay, here we have a problem-solving question. 4 equal tanks in the shape of a cylinder, and we have some fertilizer made of fertilizer and water mixed in the ratio 1 to 100. Okay, and we've got to see if there's enough fertilizer to completely fill the 4 tanks. So we need the volume of the 4 tanks, and to get that we need the radius, and the radius is 40 centimeters. So I'm just going to put R equals 40 there. Okay, and then we're going to work out the volume of the 4 tanks. Okay, and this is how I'm going to do it. I'm going to simply start forming an inequality, in fact. So what I'm going to say is that the 4 tanks have a volume of 4 times pi times the radius squared times the height, which is 160. Okay, so that's the volume of the 4 tanks in cubic centimeters. I divide that by 1000, and that will tell me the number of liters. Okay, because there are 1000 centimeter cubes in a liter rather. Okay, so that is the first thing I'm going to do, and I'm going to work that out on the calculator, and it equals 3216. Okay, and it goes on a bit after that, 0.99 in fact, but that's as far as I need to go. And I'm now going to work out over here the fertilizer. Okay, the actual volume of fertilizer. Now we have to be careful here because of course this is going to be made up in the ratio 1 to 100. So there's actually 101 parts. Okay, because it's the 32 liters of concentrate plus another 100 times that of water. So the fertilizer is going to be 32, okay, times 101, which is equal to 3232 liters. Okay, now all I need to do is put here the correct inequality sign in this space. So that is less than that. In other words, the volume of the 4 tanks is just a little bit less than this. Okay, so the question is Karina, does Karina have enough fertilizer? Yes, enough fertilizer, and that's it. And you don't need to restate that because it's up there. That's it. Okay. Okay, this question is about 2 similar triangles, and we've just got to work out lengths on each triangle. So we've got to work out the length of EF, which is on this larger triangle here, and this is 4, so what's EF? Well, we look for a common side and a comparison, and if we see the 5 here, okay, and we notice the 20, that enables us to see that the scale factor going from left to right is times 4. Okay, so going the other way, it's times 4 to go from that one to that one. So going the other way, it's divided by 4. All right, so all we need to know, we can do this really quickly. So 4 times 4 is 16. So EF equals 4 times 4. Okay, and if you like, you can say how you got the 4. Well, you got 20 over 5. So it's 20 over 5 times 4, which is 16 centimeters. Okay, and then for this one you've got to work out AB. Well, AB is over on this side, and we know that one is 22. So we just need that AB is 22 divided by 4. Okay, 22 divided by 4. Okay, and that's 5.5 centimeters. And that's it, a really easy question, but you've just got to spend a moment making sure you can work out accurately what the scale factor is. In this case, it's quite simply an integer 4. Okay. Okay, we have a probability problem here with a tree diagram, and we've just read the information we have here, and we're given some information and we've just got to complete the tree diagram. Well, these are binary situations. We either win or we do not win, right? One or the other. So the probability of winning or not winning is one whole one. So if this is 0.3, that must be 0.7. Okay. This is 0.35, that must be 0.65. And this one similarly must be 0.65. So there's 2 marks for that part. Okay. And now we've got to work out the probability that the Keddy family will win both the sports quiz and the music quiz. Well, that's basically win-win. So it's the probability of winning that and the probability of winning that, you multiply them together. So it's simply 0.3 times 0.35. Okay, and if you multiply those together, it's 0.105. And that's it. Okay. Okay, in this question we have to work with units of measurement and change them. So we've got 8,000 cubic centimeters and we've got to change it into cubic meters. Well, basically there's 1 million cubic centimeters in a cubic meter, because a meter is 100 times 100 times 100 cubic centimeters, which is a million. So we just need to divide by a million. So if we write this out properly, we've got 8,000, okay, over 1 million. We'll just cancel out some zeros. Okay, it is only 1 mark, so they won't expect you to do much in the way of working, but just to explain how it works, we'll just cancel out some zeros. So we take those 3 out. Take 3 of those out, so we get 8 over 1,000. Okay, now 8 over 1,000 is 0.008. Okay, cubic meters. Now we've got to change a speed of 180 kilometers per hour into meters per second. Well, what we need to do is we start with the 180. Okay, that's kilometers. Now change it to meters by timesing by 1,000. Okay, and then divide it by 3,600, because there are 3,600 seconds in an hour. Okay, and that comes from 60 times 60. Okay, so you could write that if you prefer, 60 times 60, to show that it's seconds to minutes and minutes to hours. Okay, and that's the calculation, and you've got a calculator anyway, so you don't need to cancel it. You can just do it on the calculator if you want, and it comes to 50 meters per second. Okay. Okay, welcome to this problem about combined means. Now, I'm going to show you this in a very sort of visual way, really, because it's quite difficult. Some people find this quite a difficult thing to do. So what I'm going to do is, we've got 50 people altogether with a mean height of 167.6. So the total length of those people is 50 times 167.6. So if we had a line that we imagined was that length, okay, I'll just write that on there, 50 times 167.6. Okay, now that line we're going to divide into the men and the women. So as far as the men are concerned, you've got 20 of them. Okay, so it's about that much of the green line roughly. Okay, and that represents a length of 20 times 182. Okay, so the remaining part to the right, I'll do that in a different colour, that must represent the total height of all 30 women added together. Okay, so if we just do that and write on there 30 times x, because we don't know what x is yet, which is what we're trying to find out. Okay, so what I can see is that if I subtract the blue from the green, I'm going to be left with the red, and then I just need to divide it by 30. So this is what we're actually going to do. We're going to take the total height of everyone added together. Okay, we're going to subtract from that the height of all 20 of the men added together. Okay, so that's going to be a subtraction sign in between those two. Now we might want to put some brackets around it. We don't need to, but it might just make it a bit clearer. So I'll put brackets around there, and a subtraction sign in the middle. And then we're dividing that by, well, if we divide it by 30, that will give us what x is. Okay, so I'm just going to put the 30 under there, and that's going to equal x, and that, when you put it on the calculator, comes to exactly 158 centimeters. Okay, so 158 is the answer to the question. Okay, in this question about standard form, we can do the first one without the calculator. It's very easy. We just need to effectively move the decimal point 4 places to the left, so the answer becomes 0.000675. Okay, now for this part, we can make full use of our calculator. So we have a button here that does powers of 10, specifically times 10 to the x. Okay, and we use that button rather than x to the power there, which makes it a bit more complicated. So use this button, and this is how we use it. We literally type this in, 2.56, okay, and then instead of putting times 10 to anything, we just press this button. Okay, so I'll just show it as a box like that, and then you type in the number 6, then you put a times sign, then you type in 4.12, okay, and then you put that times 10 to the power of button again, and then put -3, and you don't need a bracket, okay, because it understands that that number is the power of 10 that follows that button. And then you divide by, now you can either set up the fraction first, which would have been using this button here. That would have been better. Otherwise you would have needed to have put brackets around that and then divide. And then I'm going to put underneath here 1.6 and the same button again with a -2 after it. Press equals and it will give you the answer, which comes out at 6.592 times 10 to the 5. Okay, 6.592 times 10 to the 5, and it wants the answer in standard form. In this question, Peter has done something wrong when he was subtracting this expression from this one. Okay, and basically what he's done is he's not applied the minus sign to everything inside the bracket. So you just need to say what's wrong. Best way is to show how it should be done, and you just simply need to say that he should have done this. Okay, so should have done. Now it would have been x squared plus 3x plus 5, okay, and then from that he should have taken away x squared but added 2x, and then added 4. Okay, if you simplify that, it comes to 5x plus 9. Okay, and that's it. You've shown what he should have done, and therefore identified the error that he made. Okay. In this question, it's slightly unusual. We've got x and y are integers, okay, and they're given between certain values, all right? And we've got to find all the values of x that satisfy all of those conditions, okay? So what it means is this. So what could this be, this first inequality? Well, it could be 4 or 5 or 6 or 7. Okay, now y can be 5, 6, 7, 8 or 9. All right, but I also know that x plus y has to be 14. So what I'm going to do is I'm going to write what y can be underneath x in pairs that add up to 14. So 9 goes under the 5, 8 goes under the 6, 7 goes under the 7, 6 and 5, you see. They're the possible values of y. Now, the ones that I've lined up add up to 14, you see, which is the third condition that has to be satisfied. So because those three pairs add up to 14, the three possible values of x that work are 5, 6 and 7. Okay, and that's the answer. Okay, this question is about an error interval, but you've got to be a bit careful because it's not the same as rounding. This is what we call truncating. So he used his calculator to work out the value of a number. He wrote down the first 2 digits of the answer on his calculator. In other words, he ignored any digits after the 2. So it could have been a 6, a 7, an 8 or a 9, but he still rounded it down to 1.2 because he just simply ignored what was after the 2. Okay, so what the lowest number it could have been was 1.2. Okay, because otherwise he would have been writing down 1.1 if it was lower than 1.2. Okay, and the greatest number could have actually been 1.299999. But because it's less than, what we do is we say it's less than 1.3, okay, which would take you up to, but not including 1.3. And that's the error interval when a number's been truncated. Okay. Okay, we have here a question about a cumulative frequency graph that's been drawn from a table, except there are 2 different things that are wrong with this graph. We've just got to identify what they are for 2 marks. Well, if we look at the class intervals, they've already been sorted out into cumulative frequency because they each go back to 0. Okay, but what we're supposed to do is plot the end points. Instead, these are the midpoints. That's 25 and it should be 50. That's should be 40, but it's actually 20 and so on. The other thing that's missing is there's no label on the horizontal axis. So you just need to write those 2 things down. I've typed it out to save a bit of time, but those are the 2 responses I would give for the 2 marks. Okay. Okay, here we have a question about the rules of indices and powers. And we've got to just simplify this expression by raising it all to the power 4. So 3 to the power 4 is 81. Then we have to do x to the 5 to the power 4, which is x to the power 20. And then we have to do y to the 6 to the power of 4, which is y to the power of 24. And that's it. In this question here, we have to expand these 3 brackets. I normally leave the first one in place and do these two first. Okay, so it looks like this. It'll be x plus 2 as it is, and that's to be multiplied by this, which we do using first outer inner last. X times x is x squared. The outer term will be x times 4. The inner term will be minus 3x. So that will leave us with just plus 1x. And then we've got minus 3 times 4, minus 12. Okay, and now we don't call it FOIL, we just simply take the x and multiply it by each of those three terms, and then we take the 2 and multiply it by each of those three terms. So it's going to be x times x squared, which is x cubed. It's going to be x times x, which is x squared. And it's going to be x times minus 12, which is minus 12x. Then we've got 2 times x squared. Okay, we have 2 times x, and we have 2 times negative 12, which is minus 24. Okay, and now we simplify because there'll be 2 pairs of terms that match up. So the x cubed term will be as it is, there's only one of those, but we'll have 2x squared terms. There it is, x squared and 2x squared. So that gives us a total of 3x squared. Then we have an x term and another x term. We have minus 12x plus 2x, which is minus 10x. And then finally, we have a number, which is minus 24. Okay, and that's it. This question is about a pet shop with different types of fish, and David's going to choose one of the following combinations, right? A guppy fish and an angelfish, or a tetra fish and an angelfish, or a guppy, tetra, and an angel. Okay, and we've got to show that there are 555 different ways for David to choose. Now you need to make sure you show it in a logical and clear way. So I'm just going to use some algebra here. I'm going to call that G for the number for a guppy fish, T for tetra, and A for angel. Okay, and this is what I'm going to do. Okay, it's going to be the guppy fish and an angel fish. So the word and implies multiply. So G times A. Okay, the word or implies plus, which is very helpful because that's exactly what we do. T times A, and the word or again is plus, and this time it's all three multiplied together, G, T and A. Okay, and we literally underneath that can just put the numbers. So we've got 7 times 5. Okay, plus 13 times 5 plus 7 times 13 times 5. And if you put that in the calculator, you do indeed get 555, which is what you needed to show. Okay, so that's it. This is a question about finding an unknown angle in this diagram. The angle we've got to find is the angle BCD, which I'm going to label as X here. Okay, that's what we're looking for. Now, we're given information about the other angles and the diagram in general, and we got to use that bit by bit to work out what that angle X is. We also have to show our working, but what we don't need to do in this question is write down angle reasons. All right, so that can save a bit of time. So let's see what we can add to this. We're told that EAB to the size of angle BCD is in the ratio 2 to 1. So that means if this is X, this must be 2X. Okay, so we must put that in. because that's obviously going to be helpful at some point soon. All right, now we know that ABDE is a cyclic quadrilateral. That means the opposite angles add to 180. So if this is 2x, this one here, down here, must be 180 minus 2x. Okay, so I'm going to put that in there now, and that's another angle that we need to use. Okay, and I'm just going to say here that I've used this fact by saying that 2x plus 180 minus 2x, in other words, I've added those two angles together to show that they equal 180, and that's linked with that statement there, you see. Okay, and I can also see that this is 120 because it's on a straight line. ABC is a straight line. Okay, so that's 120, and because that's 120 and we're still in the same cyclic quadrilateral, that's opposite, so it must be 60. Okay, so I could say at this point on the same line, 60 plus 120 equals 180, because I've used the same fact that we're in a cyclic quadrilateral. Okay, now we're probably putting more than enough detail here, but it's good just to have some working to support what we're doing. Now we're nearly done. We've just got one more angle to do, and that's this one here, which has to be 2x. And the reason is simply because that's a straight line, EDC. Okay, so we've got 180 minus 2x plus 2x equals 180. Okay, so we now have a triangle. So I'm just going to say triangle BCD. In triangle BCD, okay, we have three angles. Okay, we have 60 plus 2x plus x, and they have to add to 180. Take away 60 from both sides, 3x equals 120, therefore x equals 40 degrees. Okay, and that's the question answered with plenty of supporting working. Okay. Here we have an interesting problem about ratio, quite a difficult problem as well. So the way I'm going to approach this is I've got these four boxes of these different weights, A, B, C, and D. We have certain information about those given there. Okay, now I'm going to start by using these two statements here, that the weight of A is 2/3 of the weight of B. So what I'm going to do is rewrite A as 2/3 of B. You see, so that's 2/3 of B, and this is still B. Okay, so the ratio of A to B is 2/3 of B to B. Okay, I'm just going to put a line across there, and then on this side, but on a different row, because these are not yet in a ratio of four things. These two are in the correct ratio, and these two things are now going to go in the correct ratio using this. So C to D is in the ratio of 3/4 of D. Okay, 3/4 of D is the same as C, and that's also D. Okay, now what I'm going to do is use the fact now that the total of A and B is 3 times the total of C and D. Now these are actually now equal to each other. So what I'm going to do is take away some of these lines, okay, and hopefully this will make some sense in a moment. So let me just take some of that out the way, and you'll see how this is going to work. So what I'm going to do next is I'm going to say, okay, that's fine. We can now say that 2/3 of B plus B is 5/3 of B. Okay, 5/3 of B. I've just added those together. That's why I've removed that divider there and put it in the middle. And I can say that that equals 3 times 7/4 of d. Okay, because 3/4 of d plus d is 7/4 of d. Need to put a bracket around that, really. Okay, now it's an equation, you see, because we're told that they're equal. So I'm going to turn these into twelfths. So I have 5 times, I need to times it by 4. So I've got 20b, or 20 twelfths of b, is equal to, now this is going to be 21 over 4, which is 63 over 12 lots of d. Okay, and that's also over 12 now. And because they're both over 12, we can just multiply both sides by 12, and therefore we can state with confidence that 20 times b is the same as 63 times d. Now, if you think about it, that means that b to d is in the ratio 63 to 20. So I'm going under the b column now, and I'm putting 63. I'm going under the d column, and I'm putting 20. And now I'm going to use the fact that a is 2/3 of b. Well, 2/3 of 63 is 42. Okay, and c is 3/4 of d. Well, 3/4 of 20 is 15. And that's my ratio there. Okay, so the answer to the question is 42 to 63, okay, to 15 to 20. Okay, now that is not an easy question, and it's easy to go wrong, of course. I just need to check that's in lowest terms, which it is, because there's no common factor of those 4 numbers. So that's my approach to working it out. There are other ways, but that's as good as any. Okay. Okay, now this is quite an unusual question about a double reflection and the single transformation that leads to. Okay, so let me explain this with a little diagram which I've produced. You can obviously sketch this in the exam, and the way I would recommend is to either do this or to use a piece of tracing paper, okay, which you can ask for in the exam. Now imagine you've got these 2 lines, x equals 2 and x equals 6. And we'll just take a random point somewhere on the axis. Let's just above the axis. Let's take this point here at say 3. Okay, now we're going to reflect it in the line x equals 2, so that will go to here. Okay, and then we're going to reflect it again in the blue line x equals 6. So it's going to go from 1 to 6, and then it's going to go up the same distance away, which will take it to 11. Okay, so that point has moved from the point 3 to the point 11. So it's moved 8 places. Okay, now we'll just try a different point. In fact, we'll even try one that starts over here. Okay, so we'll start by reflecting it from here, okay, and we'll reflect it in the red line, so it'll be here. Okay, that's the first reflection. Then we've got to reflect it in the blue line, which will actually take it to here. And you'll notice that that's also moved up 8 places. So the first one started here and ended up here. Okay, and this one started here and ended up 8 places to the right. Okay, and that will always be the case. Now I'll show you where the 8 comes from. It comes from the difference between these 2 doubled. Okay, 6 minus 2 is 4, times 2 gives you 8. Okay, and the times 2 is to do with the fact that you're reflecting it, so it goes twice as far over the line as it was, well, the same distance either side of the line. But anyway, you can easily see that that works, and you can try it with other positions to start. Now, the other thing to bear in mind is that you reflect it and then reflect it again. It'll be in the same orientation as it was before. Okay, so it becomes a translation. That's the type of transformation, a translation Okay, so the answer to the question is a translation. Okay, and the vector of the translation is 8, 0. Okay, and that's the answer. Unusual question. Okay, this is a question about probability and ratio, and we just need a systematic approach to solving it. We've got blue, red and green counters in a box. Okay, the probability that it'll be blue is 0.4. That means the probability it'll be red or green will be 0.6, because 1 minus 0.4 equals 0.6. Okay, now what I'm going to do is work in percentages, okay, because I see this number 50 coming up, and it will be helpful in a moment if we did that. So I'm just going to put the three colours in order that they appear in the question. So blue, red and green. Okay, and I'm going to start by putting the 40 with the blue, and the red and green must therefore make up the other 60%. Now, if we do, I'll put percent there because that's what we're working in. Now, I notice that 7 plus 8 makes 15, okay? So 7 plus 8 is 15, and 15 goes into 60, okay? So it goes 4 times, you see. So if I take 4 times 7 there, okay, I'll just show my working. 4 times 7 is 28. Okay, and 4 times 8 is 32. Okay, then I can split the red and the green in the ratio 28 to 32%. So 28 to 32. And you see those three numbers add up to 100. So they're now in the right ratio. Now all I need to do is, if I halve them all, take the percent sign out, I don't really need that. That gives me 20, 14 and 16, which very conveniently add to 50. So Samina does this trial 50 times, where she takes a counter and puts it back. An estimate for the number of times she'll get a green would simply be 16, okay? Because you'd expect 16 greens, 14 reds and 20 blues if you did it 50 times. So the answer is 16. Okay, 16 green. Okay, and that is the end of that question. In this question, we are asked to prove that two triangles ACE and DBE are congruent. Now, we'll start by just highlighting the two triangles that we're trying to show are congruent. So here we are. So ACE is this one here, and the other one is that across there. Okay, now they look the same size and shape. One's flipped over, but we've obviously got to prove that they are. So let's look at the information we're given. First of all, that the side AE is equal to DE. Okay, so that means that we're dealing with an isosceles triangle. Okay, now it is of course possible that we're dealing with an equilateral triangle, but that's irrelevant to the problem, because either way we'd get the same answer. The fact is those two sides are the same, which means that these two angles are the same. Okay, so the angle EAB and EDC are the same, and I can show that by putting a dot in each one. All right, and we've got two lengths other than those two that we've already said, which are the same. And if these lengths are in the ratio 1 to 2 to 1, we could call that length there x and 2x, and this would then be x. And I can say that the length AC is equal to 3x, which is the same as the length of BD or DB. So I'm going to say that AC equals DB equals 3x. Okay, I'm going to say that AE equals DE, AE equals DE, and I'm just going to put the word given afterwards because they tell us that in the question. Okay, and then I'm going to say that angle EAB is equal to the angle EDC. Okay, and I'm just going to say isosceles triangle. Okay, so what I've got here is what we call side, side, and an angle. So I just need to say, prove the triangle AC is congruent to BE, proved by SAS. Side, angle, side. Okay. This question involves completing the square on a quadratic that doesn't actually have a constant term at the end, but that's fine. So the way we approach this is we've just got to show that it has, well, we know it has one turning point because it's a quadratic curve. It will have a minimum because of the positive x squared, but we've got to complete the square to show that the turning point has coordinates 7, negative 196. So we start by just taking out the factor of 4. So y equals 4 times, okay, and it's going to be x squared minus 14x. All right. Now, to complete the square, we halve the x coefficient and square it. So that's equal to 4 times, then I'm going to open a big square bracket here, and it's going to be x minus 7 all squared, okay, which is going to give us x squared minus 14x plus 49. So I need to take away 49, you see. Okay, and then I've just got to multiply that back out again to give me 4x minus 7 squared. Okay, and then I've got to take away 4 times 49, which is 196. Okay, now the smallest value that this bracket can be is 0, because when you square something, it's always going to be positive unless it's 0. It can never be, it can't be negative. So basically, x has to be 7 to make this bracket 0. Okay, so x equals 7, and for minimum, y equals minus 196, you see, because when x is 7, this is 0, all of this is 0, and you're left with minus 196. Okay, and that pretty well proves it. Okay. Okay, in this question we have an algebraic fraction expression made of 3 parts, and we've got to simplify it to show it in this form, identifying the integers a and b. Now, to save time, I've written a lot of this out already, and I'll show you how I've processed it. So what I'm going to do is multiply this fraction by x plus 5 over itself, and that will cause the denominator to be x plus 5 times x minus 5. Okay, I need to now put some brackets around this one as well, just so that it's the product of 2 brackets, the same on the top there. Okay, and I'm going to do this one here by x minus 5 over itself, because that will also cause the denominator of this one to be x plus 5, x minus 5. And at the same time, I'm recognizing that the denominator is the difference of two squares, which is x squared minus 25 as well, which is what we have here already. And this number 3, I'm going to have to multiply that by both of those two brackets together, okay, so that we now have a common denominator all the way through. Okay, so that 3 is multiplying all of that together. Okay, now obviously it takes a while to write all that out, but basically I can now put that together with a simple single common denominator of x squared minus 25. Okay, and so it looks like this. All right, and I've just got one occurrence of the denominator on a large fraction. And now I'm going to multiply all of those bracket pairs out using FOIL. Okay, first outer inner last. And if I do that, I get this expression here. And then I just have to go through and cancel things out or simplify as best I can. And very quickly I can see that the 2x squared plus the x squared makes 3x squared, minus the 3x squared there is 0, so they cancel completely, and I'm left with 13x minus 9x, okay, which is 4x. I'll write this part out. Okay, I'm also left with three numbers on the top, 15, 20 and 75, which give me 110. Okay, and then on the denominator I just have my difference of two squares as it is, which is x squared minus 25. Okay, so I've answered the question. I can now say that, I'll just put the fraction line in there, I can now say that a is the number in front of x, which is 4, and b is the number 110. Okay, and that's the answer to the question. A question about transforming graphs. In part A, we have to apply this transformation, which moves the graph 2 places to the left, because the plus 2 is with the x, not at the end of the function. So what we do is we just take a point, say this -1, and redraw it over here 2 places to the left. And we do that with all the points, all the key points, like the peaks, the end point here. But on the pen and tablet it's very difficult, so I have already done this. So I've taken a function that looks approximately like the one we were given. Okay, that's the black line on here, and I've moved everything 2 places to the left to give me that blue function there. Okay, now on to this question. We've done a reflection in the x-axis. Okay, so what that is represented by is that y equals, write down an equation for graph B, and it's simply that y equals negative g of x. Okay, that's a reflection in the x-axis, and that's it. Okay, this is a vector proof question, and I've just got to use the information I've been given and prove that by a vector method that CF is parallel to DP. Well, at the moment we don't know where P is, but we have information to enable us to find it, because it says the point P is such that CEP is a straight line and CE is equal to EP in length. So I'm just going to draw that straight line from C through E, then take the same distance again, and that will tell me where the point P is. Okay, so it's about the end of my red line there. Okay, so that's my point P. And what we're trying to prove is that the line DP, the vector DP, is parallel to CF. Well, we can see it probably is, but that's obviously not a proof. So what I'm trying to show is that that line there I've just drawn is parallel to CF. Okay, so let me just mark it as if it were, because that's what we're trying to show. Now, what I'm going to have to do is get a vector expression for CF in terms of A and B, all right? And then I've got to get an expression for DP in terms of A and B, and then I would need to show that one is a multiple, a scalar multiple of the other, to show that they're parallel, all right? So let's do CF first of all. So the vector CF, okay, now that can be obtained by doing CD, okay, so I would tend to write it like this: CD plus DE, okay, plus EF. So it's three vectors that I know already in terms of A and B. Adding them together will get me from C to F, okay. Now I'll write those in terms of A, B and B. So I've got 2A for that part. Okay, that's the vector A. I've got minus B, and then this EF is minus A, you see. And when I simplify that, I've got 2A minus A, which is A. So that simplifies to A minus B. So A minus B is the vector CF, okay? Now, I'm just going to do something about the vector CE, okay, and the vector E. I'm just going to put those two vectors in. Now, CE is going to be equal to 2A minus B, okay, 2A minus B. That's quite simple to see that one. And because EP is on the same line and it's the same length as CE, we can also say that that's equal to the vector EP as well. Okay, they're both equal vectors. And I'm going to need that in a moment because I'm now going to write an expression for DP, okay, using that information. So D to P, okay, is going to be minus B plus this thing here, okay. In fact, what I'm doing is I'm doing D to E plus E to P, okay, if I write it out in full. That's what I'm doing to get from D to P. Now if I put in the AB substitution into there, DE is minus B and EP is 2A minus B. Okay, and when you combine all those, you get 2A minus 2B. Okay, and all I'm going to say now is that 2A minus 2B equals 2 lots of A minus B, okay, and that is 2 lots of CF, okay, which is showing that they're parallel because one of them, DP, is twice the vector CF, okay. So I'm just going to put here that DP equals 2CF, therefore parallel. Okay, and that's how you prove using a vector method that those two vectors are parallel. Okay. Okay, this is an interesting question. You just have to use the this information about density, mass and volume, which I've summarized here. Density is mass divided by volume. Okay, so you're told something about the top part of this pyramid made of a different material to the bottom part. Okay, and you've got to work out the volume of the top part as a percentage of the volume of the bottom part. So we need to get the volumes of each part. So we'll start by finding the total mass, okay, of the whole thing. So total mass, okay, and the total mass comes from the well, the total mass is simply 92.8 plus 972.8. So 92.8 plus 972.8. And we add them together and we get 1065.6. Okay, so that's easy enough. That's the first step. Now the total volume of the whole thing, that is simply going to be the total mass. So the total volume, which is what we need, is going to be that mass divided by the density. You see, mass divided by density is volume. Okay, so it's 1065.6. Okay, but I'm not going to put the point in, because underneath, instead of dividing by 4.7, I can just divide by 47, and that will be the same answer. So it saves me having decimal points in my fraction, that's all. Okay, so that's the total volume of the large pyramid. Okay, now I want the volume of just the top part. Okay, don't need to know, by the way, what that number is. I don't need it. I just need to leave it like that for the moment. So the volume of the top part, so the top volume, I'll call it the top volume. Okay, and that simply comes from 92.8 divided by the density of that part, which is given as 2.9. Okay, now when you put that on the calculator, it comes out at exactly 32. Okay, so we don't need to, we can just use 32. All right, so the question was, what's the percentage of that? What percentage is that of the total volume? Well, we just have to do a percentage calculation. So it's 32 divided by this fraction here. Okay, well, I can just make a copy of that and bring it down. Okay, and then I can put it on the calculator like that, or I could invert it and multiply. It doesn't really matter, because it's a calculator paper, but I will need to put brackets around that. And that comes to, and if I times it by 100, it puts it as a percentage, and that gives me 14.11%. So it's 14.1 to the required degree of accuracy, and that's the answer. Okay, this question is about a regular heptagon, 7-sided, and we've got to find the length GB. I'm going to call that length Y, okay, because I'm going to call these two equal sides X. I know the total area of this thing is 30, because it tells me in the question, and I'm going to call this angle here theta, okay, because I'm going to need to use that angle in a moment. So what is that angle theta? Well, if it's 7 sides, you subtract 2 from the number of sides, which is 5, multiply it by 180, okay, and divide by 7, because the 7 sides, okay, that's how you find the interior angle of a regular shape, and that comes to 900 over 7, okay, 900 over 7 degrees. It's about 128 point something, but you don't need to know that. Just keep it as a 900 over 7, because that's exact, you see. All right, so now I'm going to use this from the area rule using sine. So the area of a triangle is a half times the two sides multiplied together times the sine of the angle between them. Well, because both sides are x, that's x squared, and the sine of the angle between them is the sine of 900 over 7, okay, whatever that number is. And then we know that that will give us the area of the triangle, which we know is 30. If I rearrange that by timesing by 2, dividing by sine 900 over 7, and then square rooting, I get that x equals 60, okay, divided by the sine of 900 over 7, okay? So it's that there, okay? So that will give me the length of x. If I square root that, I've got to square root as well, because that's currently x squared. So that needs square rooting, okay? So that's quite important. So that there would give me the length of x. All right. Okay, so you can put that on the calculator like that if you wanted to, and you could evaluate it. But it's really not necessary to know what x is. Just for reference, I'll just mention it here. It's about 8.76. Okay, but you don't need to be using that in this calculation. You can just store that in the calculator as it is. Okay, so now I'm going to go to the cosine rule. And I know that y squared would be x squared plus x squared, okay, which is 2x squared, minus 2 times x, which is minus 2x squared, times the cosine of the angle between them, which is 900 over 7, okay, the cosine of 900 over 7. Now, I know what x is because I've got it here, or it's stored on the calculator. So y would be the square root of that. And what I'm going to do is take out a factor of 2x squared. So it's the square root of, okay, better put my square root sign in. Okay, it's the square root of, well, let's just write that first, 2x squared brackets 1 minus the cosine of 900 over 7. Okay, I don't really need to do that. I could have just left it in. It just means I've only got one occurrence of x instead of 2, you see, in the expression for y. And then I just need to evaluate that on the calculator, and it comes to 15 point, I'll put it down here, 15.8 to 3 significant figures as required. Okay, I'll just put 3SF there just to show that I've rounded it, but the working is clear and that's where it comes from. Okay, that's the end of the question.